This is Miss Glasgow. We are going to go over example number 3 from your guided notes. This is under the heading, Using Logs to Fit an Exponential Function to Data. And let's read the problem together. Okay, the table below shows newspaper share of the expenditure of national advertisers. Now it says they want us to fit an exponential function of the form y equals ae to the kt to the data below. So where y is percent share and x is the numbers years since 1950. So our goal in this is to fit an exponential function of the form y equals ae to the kt using the data below. Now we're going to use a chart to do this. There's going to be 5 steps. So right now I'm going to only have you write down the 5 steps, and then we're going to go over the problem. So here is step 1 through step 3. Right now I want you to pause the video so you can write these down. Okay, so now I want you to write step 4 to step 5 on your guided notes. And this is where you should pause so you can write this down as well. Good. Okay, so now we actually are going to do the solving process. So it says step 1, find natural log for each y value. Now let's go back up to our table that tells us all our y values. Let me pull this down. So here we have our y values 16, 10.8, 8, 6.7, 5.8, and 5. Now, they want us to find the natural log of all these y values. All you have to do is plug this into your TI Inspire calculators. So if you haven't done so, you might want to get that. And you would plug in natural log of 16, natural log of 10.8, natural log of 8, etc. Now what I want you to do is pause the video so you can do this for yourself and then check your answers later. So please pause the video right now. Okay, so let's see if you got your answers correct. So this is what you should have gotten when you did the natural log of all the y values. So 2.77, 2.38, 2.08, 1.9, 1.76, 1.61. Good. So that was step 1. Now moving on to step 2, it says use x and natural log y values to find a formula for a linear function. Now here what you're going to do, you need to use your TI Inspires because you're going to find linear regression. Now what I want you to do right now is go turn your TI Inspires on. If you haven't done so, you should already have them on because you have to evaluate these natural log of y values. So now I want you to go to the home page if you aren't on there right now. Now on the bottom there are these boxes, and I want you to go to the 4th box which says list and spreadsheets. And once you go there, press enter. Now you were given a reference sheet on how to calculate linear regression. You're going to use that to help you to find the linear regression of this problem. So once you've gone, you have column A and column B. So column A, as it says on the reference sheet, you're going to list the x values, so 10, 0, 10, 20, 30, 40, and 42. Now in the B column, you're not going to list the y values, you're going to list the natural log of y values. So that means you're going to put in the B column 2.77, 2.38, 2.08, and etc. Okay, once you have done that, please use the reference sheet to find the linear regression or calculate the linear regression and find the linear function. Now you need to pause the video to do so. So I would say do it right now. Okay, so you found the linear function using linear regression. Let's see if you are correct. This is where you're going to check your answers. So here we have y equals negative 0.025x plus 2.681. Now remember, m stands for slope. So when it said m, it was negative 0.25. And b stands for your y-intercept, which was 2.681. So now we just did step 2. So now we're moving on to step 3, which is rewrite the formula as natural log of y, which equals b plus mx. Now this is very simple, because all you have to do is replace y right here with the natural log of y. That's all you have to do, and your mx and b stay the same. So that was basically step 3. Now step 4, it says use the equation above to find an exponential function. So right now you're going to solve for y. Now I want you to pause the video so you can do this on your own. Now I'm going to give you a hint. The inverse of natural log is e. So pause the video to solve right now. Okay, so let's go see if you had the correct answers. So we know that the inverse of natural log is e, so we take e on both sides. So now e and natural log cancel, and we should have y equals. Now, if you didn't remember, this is your exponent laws. This was from algebra. Now, remember that addition, it corresponds with multiplication. So this is what we should get right here. So you have y equals e to the negative 0.025x and e to the 2.681. Now what I wanted to do is evaluate e to the 2.681, because there's a value right there. And we'll get approximate 14.6. Oops, let's click that out. So here I just approximated to the, or rounded to the 10th place. So that's what I meant by just use the equation above to find an exponential function. So now we're going to go to step 5, and it says write formula in the form y equals ae to the kx. So here we are just going to place in numbers, and this is what we should get. Let me pull this down. Let me bring this back up. So y equals 14.6, that was our a value, times e to the negative 0.25x. So now we have found our formula in the form of y equals ae to the kx, and this would be our answer. So this is how you would use logs to fit an exponential function to data. What I want you to do now is work on problem number 7 on page 212 and problem number 2 on page 214. These are part of your homework, and it's dealing with the same exact thing. So right now, if you need to go back to look at any of these steps, you can go, but work on problems number 7 and problems number 2.